Hey everyone, this is Eric Sloove over at ntpro.nl, and in this video we will discuss vSAN, and we will take a closer look at the components and the votes and the witnesses. Interesting stuff. So what do we have? We have a cluster with 7 ESXi hosts. They're nested in a VM. I have one big Supermicro host with 120 gigabytes of memory, and this cluster is enabled with vSAN. Every host has an SSD drive for write caching and two capacity disks, also SSD, 40 gigabytes each for capacity. And I pre-configured a lot of policies uh, within this environment. And what I want to show you is how the number of failures to tolerate and the stripe width is influencing the number of votes, the number of components, and the number of witnesses. So I pre-created a lot of rules, failures to tolerate 1 with rate 5, with stripe width 1, 2, and also I did the same for failures to tolerate 2, and even failures to tolerate 3. And yeah, I want to give a little demo and take one VM within the vSAN cluster and yeah, show what the number of components is, and also how the voting system works. So let's start with configuring one of those policies on the VM. So when I scroll down a little bit and I go to this virtual machine, and I'm going to the VM policies, edit policy settings, then this VM can be configured with the first one. Failures to tolerate is 1, stripe width is 1. So it's on the top of the list right here, apply to all. This is the default policy that is also created or used when you are creating a vSAN. Let's click on OK and let's see what happens. So when I select the hard disk and I'm checking the compliancy, I can see that I have 2 active components and 1 witness. When I go to RVC, and RVC is the command line stuff, then in RVC we can see the same. So we have rate 1 with 2 active components and 1 witness. So let's go to Excel and let's say failures to tolerate 1, stripe width is 1, components is 3, I have 1 witness components, and all the votes were 1. Vote 1, vote 1, vote 1. So the witness has a full vote, and that's how you can get a majority. If you are an active component and you are able to get more than 50% of the votes, then you are an active component. Okay, let's jump to the second scenario. Let's configure this VM with a policy based on failures to tolerate 1 and a stripe width of 2. And yeah, let's see what happens if I go for that scenario. Sometimes this takes a little bit longer because it has to check if all the hosts are still healthy, and it has to check if every host is still contributing storage, but in our case it's okay. So failures to tolerate is 1, stripe width is 2, apply to all, and let's see what happens when I go to the number of components. Okay, the machine is compliant. Oh, it's out of date. Let's check it again. If you are configuring a stripe width, then the home object of the VM is never benefiting from that stripe width because the home object is not using multiple stripes. It's only done on the hard disk object. And now when I select the hard disk object, I can see 2 stripes within 1 rate 0 domain. And I don't see any witnesses anymore. So let's check RVC and let's check what happened to the witness. So what I see now is those 2 rate 0 domains, and I can see that this has 3 votes and this one 2, and these are both 1. 1 plus 1 is 2, 2 plus 2 is 4, and 4 plus 3 is 7. So I have an odd number of votes, which is okay. When I lose one of the when I lose one of the components, I still have another rate 0 configuration, and you can get the highest number of votes, 50%. Okay, so failures to tolerate is 1, stripe width is 2, the components we saw were 4, so we had 4 components, and there was no witness, and we saw that the voting system was used. The highest number of votes was 3. Okay, let's jump to the scenario where we have 2 failures allowed. So when I go to the settings of this virtual machine and I'm selecting the policy with failures to tolerate is 2 and a stripe width of 1, failures to tolerate is 2, stripe width 1. And let's take a look what happens now. So I can lose 2 hosts, 2 failure domains, and I have a stripe width of 1. So let's check if the machine is already compliant. It's not, but it's rebuilding. Sometimes you see double the amount of components while it's rebuilding. And you also need twice the size sometimes. Okay, so the stripe width is 1, so the policy is for the home object and for the disk are the same. And what we see is 3 components, because we can have 2 host failures, and we see 2 witnesses. Why? If you add 1 witness to 3 components, you have 4 components, and that's an even number. And you will always need an odd number, so we have to add a second witness in order to get the number on 5. So let's go to the Ruby vSphere console on vCenter, and let's see what happens to the votes. Well, to the votes, nothing happened, because the witness plus the witness plus 3 components is 5, which is an odd number. So failures to tolerate 2, a stripe width 1, components 5, and we had 2 witness hosts. Let's take a look at failures to tolerate 2 with a higher stripe width. So when I go to this VM and I'm going to the policies and I'm setting the policies on failures to tolerate is 2 with a stripe width of 2, and I say apply to all, then we will see double the amount of components regarding the RAID configuration. And refresh. Oh, it's already compliant. So the stripe width is 2. We have 3 failure domains, 3 failure RAID configurations of RAID 0. And the witnesses are all gone, because now we have enough components to use the voting system without witness hosts. So when we go to take a look at RVC, we can see those 3 RAID volumes, and we can see that 1 plus 1 is 2, 4, 6, 8, 11. So it's an odd number. We have 11 votes in total, and if you own more than 50% of the votes, so it's 6 votes, that's the lowest number, then you are allowed to use to host the active component. Interesting stuff. So yeah, so with 2 failures to tolerate and 2 stripe width, we had we had 6 components, and no witnesses, and we had votes ranging from 3, 2, and 1. Interesting. Okay, so let's take a look and take it one step further. When I go to the policy and I'm configuring failures to tolerate is 3 with a stripe width of 1. Apply to all. Okay. And let's check the compliancy. Still out of date. Still out of date. Still out of date. But you can already see it a little bit because this is very interesting. And that's also the reason why you need so many hosts. With 3 host failures allowed, you need 2 multiplied by 3 plus 1 ESXi hosts in your cluster. And what we see now is that every single host has a witness component active. So I have 3 active components which I can lose. Then I still have 1 left, and every component is guarded by its witness. And now when we jump to the votes, you will see a very interesting phenomenon, because we have 3 witnesses, and when we look at the votes are all back to 1. So 1, 2, 3, 4, 5, 6, 7 votes in total. So you are allowed to host an object if you have 4 votes or more than 50%. So that's a lot of witness hosts, because we don't have enough components to be a tiebreaker. If we take it one step further and we go to the VM policies and we say, let's configure failures to tolerate is 3 with a stripe width of 2, then you will see something completely different, but maybe not, because we have a very high number of failures to tolerate. And when you have a high number of failures to tolerate, also the number of witnesses is high. So let's see what happens in this case. We have configured failures to tolerate is 3, a stripe width of 2, I think. Oh, that should be 2. Let's reconfigure this. Edit settings. Yeah, oh, it is configured correctly. The user interface was not refreshed yet. Yeah, there it is. It's compliant. And let's see what happens. So failures to tolerate with stripe width 2 is only interesting for the disk object. We see 2 witnesses and another witness at the bottom. Yeah. So we have 3 witnesses. We still have 3 witnesses, and the components are split into stripes, and every failure RAID domain has 2 of those stripes. So when we go to the command line, then we still see that the number of components has doubled, and we can see that we have witnesses with higher votes because they are more important than the votes from a stripe. Yeah, so the witnesses have higher votes than the stripes. There's only one RAID 0 configuration with a high number of stripes, otherwise we wouldn't have a tiebreaker. So 2 plus 2 is 4, 6, 7, 8, 9, 10, 11, 12, 13, and 2 is 15. So we still have an odd number of votes. So in this case, if you have 8 votes or more, you're the owner of the active object. So 3 failures to tolerate with a stripe width of 1. There were 3 witnesses, 3 failures to tolerate with a stripe width of 2. We had 3 witnesses, and we also had the votes. Okay, last but not least, when you have an SSD VLAN, you are allowed to configure RAID 5 and RAID 6. The cool thing about RAID 5 and RAID 6, I'm going to show you real quick, is that the amount of space that is used by those policies is less than RAID 1. So if you configure failures to tolerate with RAID 5, then you need at least 4 hosts. And if I go to the edit button on this RAID 5 configuration, I go to my rule set, then I can see that my primary level of failures to tolerate is 1, and I've configured RAID 5. If you configure this with, I'm forgetting the most important part, because it also shows you how big one file will be. So if you have a file of 100 gigabytes, it will take 1.33% of the vSAN capacity. If you look at RAID 6, so failures to tolerate is 1 and RAID is 6, then you need 6 hosts. You can lose 2 of those hosts and still get access to your data. And now we have 2 host failures configured, RAID 6, and we have 150% of capacity used when using an object on vSAN. So let's jump back to the virtual machines and templates, and let's go to the VM and configure this with the RAID 5 policy first. So failures to tolerate is 1, and it's based on RAID 5. What we see here is that we can check the number of active components. It takes a while because it has to do a rebuild. It's out of date, but maybe we can already see it. When you're configuring RAID 5, the VM home and the hard disks are using the same policy. Yeah, this is interesting. Now we see both next to each other, the old RAID 1 and the RAID 5, and you need double the space if you switch from RAID 0 to RAID 5. It has to recreate all the objects. It's finished, and we can see 4 active components without any witnesses. So let's take a look at the command line and see what happens with the votes. So RAID 5, 4 active components, all in their own failure domain. And what we can see is 1 plus 1 is 2, plus 1 is 3, and there's one component with 2 votes to make it odd. So that makes 5, and if you have 3 votes or more, you're owning the active components. Interesting. So with failures to tolerate 1 and the stripe width of, it's not a stripe width, but it's RAID 5, we have 4 components and 0 witnesses, and we have the voting system active. Last but not least, let's configure this machine with RAID 6. So the failures to tolerate with RAID 6 is 2, and the RAID is 6. So let's apply this to the VM and see what happens. Okay. Let's check the compliancy. The same thing that happened with RAID 5 also goes for RAID 6. Both the home object and the disk of this VM are using the same number of components. So now we can see RAID 5 and RAID 6 next to each other. So RAID 5 is still active. RAID 6 is rebuilding, reconfiguring. We can already see that we need 6 hosts, and there are no witnesses. They're compliant, so let's see what the final result is. I have a RAID 6 volume with 6 active components. Let's take a look at the votes, because with 6 components you don't have a majority, as every component has only 1 vote. So with RAID 6 we see the same thing happening. 1 plus 2 plus 3 plus 4 plus 5, and then we have 2, which makes it odd, which is 7. So that brings this video to an end, and as a rule of the thumb we can say if the stripe width is 1, then the number of components minus the stripe width is the number of witnesses. So what we saw is when you have a stripe width of 1 and you have 1 failure to tolerate and you have 2 components and 1 witness, then 2 minus 1 is witness. The same goes for if you have a stripe width of 1 and you are doing 2 failures to tolerate. So we had 3 components and 2 witnesses. So stripe width is 1, the number of components minus the stripe width is the number of witnesses. And the same was true when we did the tree. So the stripe width is 1, and we had 4 components and the stripe width was 1, so 4 minus 1 is 3 witnesses. Thanks for watching this video, and I hope to see you back soon. Bye bye.